We start off the second class, third class, which is network setup, configuration, and troubleshooting. Most of the things we describe in this class, you can actually carry them out on your own if the need arises. So, networks are now the building blocks of every successful organization. There's no organization that does not try as much as possible to put up a network because whatever kind of business they are doing, they are going to interact with people and with other organizations that may not be in the same vicinity. And so, since they are not in the same vicinity, they need to communicate and share files among themselves. A network makes it possible. So, there's a genuine concern for the need to understand how these networks are set up. So, this particular class will guide you through the steps to set up, configure, and troubleshoot a computer network. Our intended learning outcomes. By the end of this particular unit, which we are going to cover, you should be able to identify and choose appropriate network devices to create solutions. You should be able to terminate different media types. You should be able to communicate, configure devices, and establish connectivity among them. You should be able to correct errors during configuration. You should be able to design network cables. You should be able to set up a simple local area network. And you should be able to test connection using ping command. Ping command. First of all, start this part of the class with what we understand by network devices. What we understand by network devices. Networking hardware or network equipment or computer networking device is just that is just a synonym for the same particular device. So networking hardware can also be known as network equipment and can also be known as computer networking device. And it is an electronic device that is needed for communication to take place in a network. These electronic devices include gateways, routers, network bridges, modems, switches, hubs, repeaters, firewalls, and other related hardware. All these devices work in different layers of the computer network. For instance, cables are used to connect devices to the network. Routers are serving as gateways to the internet. Let's look at the repeater. This one is an electronic device that regenerates a signal in order to extend the length of transmission. For instance, you are broadcasting from a particular base and you want it to cover maybe a school environment. You need to mount repeaters in different places. So as the signals are getting weaker, the repeaters will pick them, strengthen them, and move them around as if they are fresh signals, so they don't get weaker. Repeaters can be considered as devices that receive signals and later retransmit these signals with higher power to reach long distance. A repeater operates at the physical layer. So what you have there is the diagram of what a repeater looks like. Then you have a network hub. That's another device. A hub is used to connect different nodes in a network. It can also be used for transferring data. Hubs are considered less intelligent as they cannot filter packets. For instance, if a packet is sent by a node to the hub, the packet will be copied to all its ports, and the port that the packet is meant for will claim it. The next one is the switch. A switch connects different devices in a network. It uses packet switching in receiving, processing, and forwarding packets to their destination. Unlike the hub, the switch only sends packets to the intended receiver instead of the broadcast method of the hub. For this purpose, switches also maintain a content addressable memory, that is CAM, content addressable memory table, with its own configuration and memory. It is a data link layer device. They have the router. The router. The function of a router is to route traffic across different networks. The routers can be an organization's intranet to the internet. An organization may maintain its own network that almost look like the internet within. We call it intranet within the organization. But when it goes out, it is now connected and called the internet. Routers are responsible for directing traffic in the network. Routers can be considered as a traffic police, directing traffic to all directions, and it operates in layer 3 of the OSI model. We also have the bridge. A bridge is a device connecting different network sections that connects multiple network segments. It can be seen as a repeater with additional functionality. That is, a bridge is almost like a repeater, but with additional functionalities to filter packets by reading the MAC address that contain the source and destination nodes. If routers are connecting different type of network, then the bridge is connecting sub-networks that are parts of the same network. It works at the data link layer. So let's look at what a bridge looks like. The device circled in red in figure 3 is a bridge that connects different network segments, bring them together. Then we check another device we call gateway. Gateway is an interface to connect two networks together by converting their transmission speed, protocol code, or security measure. They are just like messengers. What they do is to collect information, interpret that information, and then forward it to other systems. Gateways are mostly called protocol converters operating from any layer. These devices are quite complex compared to routers and switches. Then there's another one again, the one that now converts your analog signal to digital and digital to analog. It modulates and demodulates. We call it a modem. A modem is a device that modulates and demodulates signals between a computer and a telephone line. What we mean by modulation is when you convert from digital signal to analog signal. That is from the computer into a form that can be now transmitted by telephone medium. Then what you call demodulation is when it gets to its destination, now converted back from analog to digital. So if you look around, you get an internet connection from wires to your house. These wires are used to carry data to the outside world. The computers are generating data in the form of ones and zeros, whereas wire carry analog signal. So there's a need for modem to do the translation. Firewall, another one, is a piece of hardware or software that prevents unauthorized access to a network. It could be hardware, it could be software, or both. It establishes a checkpoint for all packets coming from the external network, thus securing your internal network. Then you now talk about that. Those are the network devices we'll be talking about. So let's look at the network cables. The various network cables are available. There are many of them. Use the real world application. And so some of them are listed below. Unshielded twisted pair is a form of network cable. And the wires here are twisted with one another, and there's no shield. What you mean by shield means there's no other rubber or plastic that protects this particular wire. It just left on its own. So this is called unshielded twisted pair. That is the outer jack. That is the twisted pair. That is the color-coded plastic insulation to protect the wire inside. So you have the shielded twisted pair. You have the outer jack, the overall shield. You have the pair shield. That is what shield them. You have the color-coded plastic insulation. This is the shielded twisted pair cable. So here now you now see the twisted pair shielded inside the pair sheet, which is just like a plastic, and so that they are now protected. The unshielded are not protected, so that is what makes them to be different. Then you have the coaxial cable. Coaxial cable are similar to a cable television cable. When you open it, you see one thin, long wire inside it, and then it is covered with a plastic container with some other devices inside. So you have the outer jacket, the braided copper shielding, the copper conductor, the plastic insulation, and so on. Cable preparation. What do you mean by cable preparation? In cable preparation, the type of the connecting devices gives a clue of which type of the prepared cable is to be used. In our cable preparation, there are standards of the color combination which are categorized into T568A and T568B standards. The next figure shows the color combination of each standard at the starting end of the cable. T568A, T568B. So you see the color combination standard, and notice that they are not actually the same, the way they are arranged. Cable preparation, straight through. The straight through is the most common type of Ethernet cable and is used to connect dissimilar devices. When you say dissimilar, devices that are not similar, such as computers to hubs or switches, switches to router, router to hub, are shown in the next figure. So that is straight through cable. Directly, it connects them together. Cable preparation for straight through. You have the RJ45 pin, then the wire color, white or orange, like that, the diagram end. Then you have orange, you have white, green, blue, white, blue, green, white, brown, brown. Continue like that as the case may be. So these are the straight through color combination for your cables. Trace cable preparation, crossover cable. Crossover Ethernet cable is more commonly used in connecting a computer to a computer, a router to a router, switch to a switch, like we are seeing here. They may be a little harder to find since they are not used nearly as much as straight through Ethernet cable. Colors and numbers of the wire is presented in our next figure. So you have the crossover cable, the different color, RJ45 pin, number, N1, wire color, white, orange, diagram N number 1, RJ45 pin, number N2, wire color, diagram N2. So you have the color like that from the beginning and what ends them at the end of the day. Roll over cable. Roll over cable. What do you mean? This type of prepared cable is used in connecting a router or switch to the PC via the console port for management or configuration purposes. Color combination of the cable ends are made in reverse order, as shown in our next figure. The RJ45 pin number end 1, you have the white color, diagram end number 1, you have it there. RJ45 pin number N2, you have the wire color, diagram end number 2. So it's just a reverse. So you check what you have on the left, reverse it, you have it on the right. So it's called rollover cable. Hands-on cable preparation, where we are told that we can actually prepare a cable by ourselves. You need some apparatus, or yes, some equipment, or some tools. The Ethernet LAN tester, twisted pair cable C85 and C86, the routers and the switches, and then you follow the steps below to prepare and test straight through and crossover cable. Start by stripping off about 2 inches of the plastic jacket off the end of the cable using a stripper. Care should be taken at this juncture so that you do not cut into the wire. If you cut through the wire, it can be destroyed. You should be checking the wire once there are cuts, just discard it and start again. Step 2, separate the wires, but be certain that you are holding onto the jacket with your other hand. This is because the wires can get untwisted inside the jacket. Category 5 cables will always have ½ inch of untwisted wire at the end, else it goes out of specification. At this juncture, you are having a lot more than ½ of an inch of untwisted wire. Step 3, you have 2 end jacks, which must be installed on your cable. If you are using a pre-made cable with one of the ends whacked off, you only have one end to install, the crossed over end. So use the color combination before 9, figure 6 and figure 8 to prepare straight through and crossover cables respectively. Step 4, test the prepared cables after installing the RJ45 connectors on both ends of the cable using a LAN tester until the signals on the tester show that the cable is well crimped, that is well connected and placed in good order. Another hands-on simple network configuration is what we have to do. Here we are going to configure a simple local area LAN network. Most times, a LAN is confined to a single room, a building, or a group of buildings. However, one LAN can be connected to other LANs over any distance through telephone lines and radio waves. Majorly, LANs connect workstations and personal computers. Each node that is individual computer in a room has its own central processing unit with which it executes programs, but it also is able to access data and devices anywhere on the LAN. What we need for our apparatus, we have a straight-through cables, we need computers, we need routers, we need switches. So we are advised to follow the steps below to set up a simple local area network. Step number 1, plug the switch to power and make sure it is on. Step number 2, connect one end of a straight-through cable to one of the Ethernet ports available at the back of the switch and make sure the green or purple light is blinking, showing that it is properly connected. Step 3, connect the other end of the straight-through cable to the Ethernet port available on one of the computers and make sure the green or purple light is blinking. Step 4, repeat step 2 above until all the computers are connected with the switch. Set an IP address to computers, which is static. Control panel, go to control panel on one of the computers. From there, go to network and internet, go to local area connection. Properties are select Internet Protocol version 4, TCP IP v4. Type 192.168+2+1. That is the space provided by IP address. Type 255.255.0 in the space provided for subnet mask. Type 192.168.210 in the space provided for a default gateway. Click OK. Do the same for all the computers. To make sure all the computers are connected, use ping command. Go to the command prompt of one of the computers. Type ping followed by the IP address of any one of the computers of the network and hit enter. If the computers are connected, the ping will be successful. Otherwise, it will fail. I agree that these your nodes are not much. You're supposed to cover 2 or more units so that we'll be able to adjust and finish everything on time. In conclusion, which network cable can best your chances as a network engineer in the company? Can we answer the question? Which of the network cable can improve your purpose as a network administrator engineer in the company? Which network cable can boost your chances or purpose as a network engineer in a company? I'm waiting for contributors. Contributors, please. I asked a question which I expect all of you to even go through. Which network cable can boost your purpose as a network engineer in a company? Any volunteer?
Okay, sir. Good evening, sir.
Good evening, sir.
Okay. I think the best, the network cable that will be best as a network engineer is the fiber optics cable, because it's faster, and computers are getting faster, so they'll need a faster medium to share information amongst themselves. So for me, the best network cable would be the fiber optics cable, although it's expensive, but still the best to me.
You have even said it's very expensive. I still the best to you. That is good. Okay.
Yeah.
Any other contributor? There are 5 in class. I can't hear. I think total number of places in your class are
Hello,
20.
sir.
Hello?
Hello, sir.
I can hear you.
Yes, sir. I agree with him on active fiber. Apart from the number of the data usage and the number of users for the organization require that kind of speed. Because when you are dealing with trade data that has to do with e-payment and import-export, you require a speedy cable. So I think the optic fiber, regardless of the price, is the best to go for my type of organization.
You are correct. Any of the ladies to talk? None of them have spoken at all. Any of the ladies? Later they say I'm not giving them opportunity to talk. Any of the ladies can also contribute. Which network cable can boost your purpose as a network engineer?
Okay, sir. I believe some of them are on transit, so they might not be able to speak right now, but maybe they might type it.
Okay. Do we have any question? Any question to ask on our own before we terminate? But your class next
Hello,
week.
sir.
Yes.
Hello, can you hear me? Hello.
I can.
Hello, can you hear me, sir?
I can.
Okay, thank you. Good evening. My name is Tijani. Sure. So regarding this question, I want to ask, can we say the network cable that will best fit one purpose within an environment should actually be what you determine that cable to be the kind of network that one has within that establishment we are from. Though I made the class in the middle, and I know there have been series of cables mentioned. So my question actually is that should there be a particular kind of cable, or what should determine the cable will be the way the network is structured? Hope you got my question, sir.
I got your question. And I was going through the note again.
Hello, can anyone hear me?
I can hear you. When you talk about cables.
Hello. Oh
we
God,
can
I have
hear
a
you,
bad
sir.
network.
We can hear you. So when you talk about cables generally, the physical transmission process, we have the coaxial, we have the twisted pair, and we have the fiber optic. But in a network, the wires we have are unshielded twisted pair, shielded twisted pair, and coaxial cable. There's no mention of fiber optic here. So the best, according to the three, I think it can either be the shielded twisted pair or the coaxial cable. One of them is better than the others. can't hear you. You're having network challenge from your side. So that is for the network. Any question?
Sir,
Yes.
if we are comparing quasar and the shielded and unshielded twisted pair, I think the shielded twisted pair would be a better option.
I'm having a serious network challenge. Quasar might rather be effective, but since it is just one data point, it might also be compromised. The shielded twisted pair will be better. But for choice of cable, generally, fiber optic is the best. Do you have any questions again? This many of you are in transit. I'm also on transit. I'll soon be leaving the office and going home.
As for me, there's no questions. Thank you, sir.
Okay, but for your class next week, I think it will be a bit longer. Because I just saw that if we continue at this pace, we will not finish the material. So we just compress 2 classes into one, 2 classes into one, so that I can move at a faster rate. From next week, please. So if we leave the class today, then I'll be the one owning you because I've not uploaded your material or video to your learning management, to your NAM portal. I think I should try and do that before we come for our next class. Everything should be there. And then if we have a class we are having on Monday, either the first or the second one, you should have the notes already embedded on your site latest Sunday, that you can be reading them. So thank you.
That's fine, sir.
Class possible.
Thank you, sir.
Even though it was short,
thank you, sir.
We'll meet next week and make it a bit longer. How many weeks have you've done your lectures now? This should be your 5th week.
Yes, I think it's 5th week.
Yes.
It's the 5th week, yeah.
By 2 weeks' time, we should be able to meet up. We'll meet up and catch up, and that will be okay. So there will be consistency now. There will be no break in transmission in terms of this class. So next week, it will start by 5, and maybe 5:15, and end by 7. Next 2 weeks, it will be the same thing. Continue until we have exhausted the period. So take good care of yourself. Enjoy the night ahead.
All right, thank you,
Thank
sir.
you, sir. Bye.
Good night.